Now, today we are going to deal with the module 2, elastic properties. In this, we go with the basics. What is elasticity? Now, we are going to see few definitions before we start up the actual topic. Deforming force. Deforming force is a force that produces deformation, that is, change in the dimensions, that is in the length, volume and shape to the object. So what is a deforming force? Deforming force is a force that produces deformation to the object. That means there may be changes in the dimensions like length, volume and shape of the object. So such a force is called as a deforming force. Deforming force is nothing but is the force that produces deformation, that is change in the length, volume or shape to the object. Next we go with the restoring force. Restoring force is a force equal and opposite to the deformation force that come into play which try to restore the body to the original state. On removal of the deforming force, restoring force bring the body to the original state. This is like a action and reaction. Restoring force is nothing but a reaction for the deforming force. Restoring force is a force equal and opposite to the deforming force that comes into play which tries to restore the body to the original state. So, after this deforming force has been removed, because of restoring force, it tries to come back to the original shape. Next is elasticity or elastic property. Is the property of a material by virtue of which they regain their original shape and size after the removal of the deforming force that is acting on them. Now what is elasticity? Everybody knows. We see the rubber band. If we give an up force to both the ends of the rubber band, it stretches. That means the length of the rubber band has been increased by the application of the force. And on removal of application of the force, it comes back to the original shape. So this property of materials by virtue of which they regain their original shape and size after the removal of the deforming force that is acting on them. This property is called as elastic property, or it is also called as a phenomena elasticity. Next is plasticity or plastic property. Plastic property or plasticity is the property of a material by virtue of which they retain their deformed shape and size after the removal of deformed force acting on them. That means it is retaining the shape that has been changed. That property is called as a plasticity. That means both are opposite to each other. Elasticity and plasticity are opposite to each other. Elasticity comes back to the original position. In plasticity, it will be in the position which they have been deformed. So these two are totally opposite in nature. So now we understood what is elasticity and what is plasticity. Next is classification of materials. Materials are classified into two groups based on their elastic property, namely, so here the materials are being classified into two categories, that is elastic materials and plastic materials. Elastic materials are the materials which regain their original state on removal of deforming force. For example, quartz, steel and rubber. Just now I have explained with a rubber band. So elastic materials are the materials which regain their original state on the removal of the deforming force. These are the few examples. Next is plastic materials. Plastic materials are the materials which are not able to regain their original state on removal of deforming force. For example, putty, clay, mud wax, lead, chewing gum. So what is happening here in this is once there is a change in the shape of a body, it is remaining fixed. On removal of the application, on removal of the force, it is in that fixed position where it has been changed. So these are the two types of materials, elastic materials and plastic materials. Note, in general, no material is perfectly elastic or perfectly plastic. Now we see few more definitions. What is load? Load is external force acting on the body that produces a change in the dimensions of the body. So what is load? Load is nothing but the application of external force that produces a change in the dimensions of the body. Next is stress. Stress is the restoring force per unit area of cross section of the wire or the rod. Stress is equal to force per unit area of cross section, that is F by A. Units are Newton per meter square. Now we see the types of stresses. There are three types of stress: longitudinal or the tensile stress. It is a stretching force acting per unit area of cross section of the solid along its length. Force is applied normally to cross sectional area. Longitudinal stress produces a change in length only but not in the change in the volume. This longitudinal or tensile stress is nothing but a force acting per unit area of cross section of a solid along its length. If there is a change in the length, or if you are applying the force along its length, then it is called as a longitudinal or a tensile stress. Force is applied normal to the cross sectional area. Longitudinal stress produces a change in the length but not its shape and volume. When there is a longitudinal stress is nothing but when the application of force is along the length, and due to this change in the length. Example, a rubber band. Next is a bulk or the volume stress. It is a stress in which the body is subjected to equal forces normal on all the surfaces. That means like a balloon filled with air. Now for the same balloon, fill it with water and give some holes to the balloon. When you apply the force to the balloon which is having water with pores, what will happen? Water starts coming out. So this is called as a volume stress. It is a stress in which a body is subjected to equal forces normally on all the faces. Bulk stress produces change in the volume of a body but not in the shape. Change in the volume of a body. See here, there is a bulk stress means there is only subjected to equal forces normally on all the faces. Normal. It is normal. Application of force is normal to the is subjected to equal forces normal on all the faces like a balloon. Bulk stress produces changes in volume of a body but not in its shape. Next is shear stress or tangential stress. It is a force acting tangential per unit area of the body. Shear stress produces change in the shape of the body but not in the volume. So shear stress or tangential stress, it is a force acting tangentially per unit area of a body. It is tangentially. You know what is a tangent to a circle? The same way, it is a force acting tangentially per unit area of a body. Shear stress produces a change in shape of a body, not in the volume. Now we go with the strain. Strain is a ratio of change in the dimensions of the material to the original dimensions. It is nothing but the ratio. It is a ratio, so it doesn't have any units. Strain is change in dimension to the original dimensions. What are the types of strain? There are three types of strains. That is longitudinal strain. It is a ratio of change in length delta L to the original length capital L. So longitudinal strain is given by change in length by original length, that is delta L by L. So along the length there is a change in length. So that becomes a longitudinal strain. Now volume strain is a ratio of change in the volume to the original volume, which is nothing but volume strain is equal to change in volume delta V by original volume capital V. Next is a shear strain. It is a ratio of lateral displacement between the two layers delta X to the perpendicular distance between the two layers X. So it is a shear strain. It is lateral displacement between the two layers by perpendicular distance between the two layers, that is delta X by X. So these are the three types of strain. Longitudinal strain along the length, volume strain change in the volume delta V to the original volume V, and shear strain ratio of lateral displacement between two layers to the perpendicular distance between the two layers, that is X. So these are the. Now we see the engineering importance of elastic materials. The knowledge of elasticity is very important in engineering applications as follows. Now you all might be having, why do we need to study all these materials? Since you are studying engineering, you should know what exactly the elastic materials and how it is used in the engineering level. The knowledge of elasticity is very important in engineering applications as follows. By knowing the elastic properties of different materials such as tensile strength, ductility, elastic limit, plasticity, stress-strain relationship, various moduli of elasticity, and how the above properties can be altered, etc. Engineers can make a better choice of materials for their use in different branches of engineering. So what exactly it says is, if you know this strength, tensile strength, ductility, elasticity, elastic limit, plasticity, you can choose a better choice of material for a particular use of materials. Example, pure materials are soft, hence they are not preferred for engineering applications, whereas alloys are harder, they find wide applications in engineering. So this is how pure metals are soft, you cannot be used for engineering applications. So if you mix some other metal to the pure metal, it becomes an alloy which is strong and we can use for many applications in engineering. So the study of metallurgy deals with this use of materials or metals for different applications of engineering fields. So this is the engineering importance of elastic materials. Hope you understand the session. Thank you.